Hello, everyone. I'm Anna Plotkin. I would like to welcome you to the second day of Ontario Association of Pathologists annual general meeting. Today we'll have an excellent program, and I hope you were able to join us again. First of all, I would like to follow up on a few questions that were raised yesterday to Michael Polanin, and I'll answer them what he said. So first question was, does COVID triggers DIC causing death? So Michael provided the insight. We have not seen DIC in COVID-19 cases, but there is a suggestion that an increased incidence of thrombosis and thromboembolism. Second question was with regards to COVID in stillbirth, and Michael said that they refer all the cases to Mount Sinai. And third question was with regards to hospitals performing hospital medical autopsies and the pathologist losing competence. So what he said, my view is that pathologists need to be careful about doing postmortem examination if they do not make it a part of their routine practice. The precise number of cases will be determined by the availability of consultation, the infrastructure in the department, and the level of professional interest in autopsy work. So this is the follow-up from Michael Polanin. And I had a couple of questions after Suha's presentation that he complemented Victor Strawn's presentation. And I'll quickly update you. There was a lot of confusion with regards to APP. And Suhas just said they started the conversation. They don't have the date of implementation yet. Another question was if there is a difference for incorporated versus salaried position, and he assured that will be no difference for two types of position. And he said also it will make part-time compensation easier. So I hope all of you who ask those questions can hear the answers. And I'm thrilled to start our second day, and I would like to start it from excellent presenter who is with us right now, Gino Sommers. He's a pediatric pathologist with over 17 years of experience. He has been a division head of pathology at the Hospital for Sick Children since 2013. Over that period, has navigated the murky waters of medical and laboratory administration, has been able to grow the division, develop cutting-edge diagnostic techniques, and has found efficiency by using lean management principles. His main academic interest is pediatric sarcoma and test development for pediatric cancers. He's a full professor in the Department of Laboratory Medicine and Pathobiology at the University of Toronto, and he's currently president of the Society of Pediatric Pathology. Gino, we're very lucky to have you here, and thank you for joining us. The floor is yours.
Hello, I'm Gino Sommers. I'm the Division Head of Pathology at the Hospital for Sick Children, and I'm a professor at the University of Toronto. Today I want to talk about how small changes can have a big impact and how they can find efficiencies in what is an inefficient system, the system being laboratory medicine. So what I want to do today is describe the basic principles of the lean management system. Some of you may well have heard of it in relation to the manufacturing sector. I want to show you examples of how we can apply lean principles to laboratory medicine to find efficiencies. And I want you to be able to leave this talk visualizing opportunities for improvement in your own laboratories. So first, a little bit about lean principles. Lean is a management system devised originally by James Womack, who was a political scientist. It was devised back in the 90s, and the principles were very avidly and successfully taken up by the Toyota car company in manufacturing plants. And again, those of you who know a little bit about lean probably know this history. It was picked up by healthcare probably in the late 90s, early 2000s as a way of trying to find efficiencies. And it was applied with varying degrees of avidity and success. But what I want to show today is that by using it in the correct way and in a judicious manner, lean can really help you find efficiencies in your systems. So the application of lean methodology to healthcare relies on three very simple ideas. Firstly, you want to deliver value from your patient's perspective. And what does that mean? That means really an accurate result. Obviously, the patient wants your result to be accurate, wants your result to be relatively fast, doesn't want to be waiting months for a biopsy report. And from a systems point of view, we don't want it to be that expensive. So accurate, fast, and cheap is probably the deliverables that as laboratory physicians and laboratory directors we all really look for. The other principle is continuous improvement. So not only do we deliver value, but we look for ways of continuously improving on that value. Don't settle for the status quo. And one of the best ways of looking for improvement is the elimination of waste. Basically things that don't bring value to the end product. Now, by waste, so what are the types of waste in healthcare? Well, there's 8 listed here, but there's 3 that I want to focus on, and each of the examples I'll give is a good example of one of these types of wastes. Defects include things like failed immunostains or poor assay design. Failed immunostains, I'm sure we're all aware of failed immunostains and how they add a day or two to your turnaround time. Poor assay design means that an assay that was originally designed for one thing ends up not delivering that one thing, and you need to go back and redesign, and you'll see a good example of that. Weighting is probably the one area of waste that we're all familiar with. For example, bottlenecks in slide production. Why is there batching in certain areas? Why do slides pile up after being cut or after being put in the oven or before cover slipping? And decalcification is a really good example of weighting. I think we all understand, those of us who work in pathology, the frustration at waiting for something to be decalcified before we can sign it out. And the third thing here that I'd like to give an example of is over-processing. And I've got a very good example of unnecessary levels. Why do we cut so many levels for certain things? And certainly outdated tests on the menu. We do not need to keep outdated tests on the menu and all the quality assurance and quality control measures that go with these tests that we might use once or twice a year. So all good examples of where you can find efficiencies in your own laboratories. The case examples that I will be talking about today include the design of a nanostring molecular assay and how that first design was defective, autopsy reporting and our turnaround times and how we could improve, or how we did improve those turnaround times, a good example of waiting type waste, and our GI biopsy slides. Why did we cut so many levels when in fact we didn't need to? And that's a good example of over-processing. So let's talk about the nanostring assay. We were tasked several years ago with finding an assay that would detect sarcoma fusion transcripts, and it had to be a multiplex assay, meaning it had to pick up multiple fusions in the one test. Our RT-PCR assays were great, but they only picked up one fusion per test, and we needed something that picked up more than one fusion because there was an exponential increase in the number of fusions that have been discovered for certain tumours. So it needed to be multiplexed. It needed to be used, or to be able to be used, on formalin-fixed paraffin-embedded tissue. The analysis of the results needed to be simple with minimal bioinformatics, because that was, you know, I'm a pathologist, I'm reading the result. I'd like it to be fairly simple. And the turnaround time needed to be relatively short, because in the most part we're talking about malignancies and we don't want to be waiting weeks for a result. So all up, NanoString fitted the bill on all those four requirements, and we went ahead and designed the assay. The assay relied on a reporter tag, which you can see here. This is reporter tag, or also called probe A, and a capture tag, or probe B. And the reporter tag had the first part of the fusion transcript, the first gene, and I give an example, EWSR1 for Ewing sarcoma. The capture tag, or probe B, had the other partner gene. It had FLY1, for example, in Ewing sarcoma. And only when that fusion transcript was present did the two probes meet and get captured. And that was how we got a positive result. But because the reporter tag only had that one gene, the EWSR1, it did not give us any idea as to what the partner gene was. The results that we generated are seen in this table, and you can see that we basically had a glorified fish test. I could tell that there was an EWSR1 rearrangement, but I couldn't tell you the partner. And the Ewing's family of tumours have lots of different partners with lots of different prognostic implications and lots of different therapeutic implications. Same with alveolar rhabdomyosarcoma and inflammatory myofibroblastic tumour and a few of the other tumours listed here. So it was a good example of a defective design that made the assay essentially not deliver what it was supposed to deliver. So how did we change that? And this is, I think this is a good example of a small change. So what we ended up doing was we had to find a way of making this probe A unique so we could pick up the partner gene sequence. Well, all we did was shift it so that the reporter tag had a little bit of the sequence of that partner gene. So it crossed the breakpoint. And that essentially shifted the test from a glorified fish test to, which is listed here, to a much more robust and thorough molecular test that gives us the partner genes in each and every one of these assays. The example here is that this was a change of maybe 5 base pairs, and it made a huge difference to the usefulness of the assay. You have to remember that at the time we were designing this, NanoString had never been used to pick up fusion transcripts. So it was a great design principle of that small change of 5 base pairs all of a sudden gave us a much more robust test, and it is being used still today. As you know, we've now got around 200 fusion transcripts that we can detect. So a really good example of small change, big impact. My second example of small changes, big impact relates to our autopsy turnaround time. So from molecular to autopsies. Our autopsy turnaround time when I became division head were suboptimal, to say the least. We had a target of signing out 80% of our autopsies within 90 days. And the years leading up to 2013, you can see that we didn't reach that by any means. 26 to 48% were signed out within 90 days. And I took this on as a lean project. We did, the value stream map, we did the walkthrough, we did everything we were supposed to do for the lean project. And what we actually found was that if we took a 90-day turnaround time as an example, of those 90 days, approximately 80% of that time was spent waiting. And by waiting, I mean waiting for the tissues to be embedded, waiting for the blocks to be cut, waiting for the slides to be stained, but most of all, waiting for the pathologist to look at the slides and finalise the report. And that was the biggest delay, was the slides sitting on the pathologist's desk. So we had to change the way autopsies were done. And we had to look at why did the slides sit on the autopsy pathologist's desk for so long. So the root cause, or the actual reason why they sat on the pathologist's desk for so long, was several, and very understandably why they were always put to the bottom of the pile. I'm going to start with the third reason here. Autopsy reports were not the top priority. Other work takes precedence, and that's understandable in a busy academic pediatric hospital. Lots of other things come and are of urgent nature. But there's certainly ways of making autopsies, I wouldn't say the top priority, but still a priority. The other two reasons there, no burning platform for reducing TAT or turnaround times. There was no real reason for pathologists. Why do I need to worry about signing out my autopsy? I never get any issue with it. Well, we were getting issues with it. People were just not aware. And the other reason there is no visibility to the status of outstanding autopsy reports, and that's really important. I want you to focus on that. No visibility to the status of outstanding autopsy reports. That meant that you got your slides, you put it on your desk or your shelf, and you kind of, out of sight, out of mind. It wasn't on the top of your list. So how did we fix the way that autopsies were looked at? So the solutions that we came up with were, making autopsies more visible. And you can see here visibility to performance, the top left-hand corner here. We had a whiteboard in our office area that was visible to all the pathologists. So whenever they walked into the office, they would see the list of autopsies, the list of names, and where they were at in the 90-day turnaround time we expected. We had huddles, so every week we would meet around the board, we would discuss the cases, and we would discuss the reason why a certain autopsy was over 90 days and how could we help that person sign it out within the 90-day period next time. What are some of the barriers that we could overcome? We had colours, so red dots were for over 90 days, yellow dots were between 60 and 90 days, and green dots were still under 60 days since having done the autopsy. So it was a very visual and weekly visit to that board that helped pathologists make them realise that it's a priority, and B, give them a real sense of where their autopsy cases were sitting. We also devised a timeline tracker, a sheet of paper that went in the report that helped the pathologists do each task according to timelines so that they would get it out within 90 days. We had calendar reminders, and I kept reminding them the burning platform that we really do need to sign it out for CAP accreditation and so on. But after having done this for 3 or 4 years, what we found helped sustain the change was really just two things, and that was visibility to the performance of autopsy sign-out and awareness of key metrics, so the dots. So basically, the whiteboard with the dots was the major change. And you'll be pleased to know we've transitioned from an analog whiteboard that actually sits on the wall to a digital whiteboard that we show after every rounds as a Word document in the office, in the conference room. And this has produced some fantastic changes in our autopsy turnaround times. Remember, prior to implementation of this little project, we had about 26 to 48% within 90 days. After the implementation of the project, you can see here, it's around 70 to 80% within 90 days. So a big difference. So essentially, a small change can make a big difference in turnaround times, and certainly the weighting aspect of waste. So we've spoken about the molecular assay and the waste of defective design. We've spoken about autopsy reports and the waste of weighting. I want to now talk about GI pathology or surgical pathology and the waste of overprocessing. Traditionally, at SickKids, we would cut 3 levels per biopsy part for GI endoscopic biopsies. That meant 3 slides were looked at for each anatomic site biopsied. However, what happened was that over several years, we had an exponential rise in endoscopic clinics and concurrently a rise in the GI biopsy parts, so that when I started as a fellow in around 2004, we were doing maybe 2,500 biopsy parts a year. By the time I became division head in 2013, we were doing just under 8,000. So that meant lots more levels, lots more slides, increased time for the technologists, increased time for the pathologists, and obviously increased cost and resource allocation for the GI biopsies. So we looked at the question, was there any value to doing 3 levels, or could we reduce it to 2? And we did this as a QA project. I did this with Dr. Siddiqui, one of our pathologists, and we decided to look at the distribution of granulomas. We looked at a focal disease. Diffuse disease you're going to see in every level. It didn't really test the premise that we could drop a level. So we looked at a focal disease. We looked at Crohn's disease. And essentially, to cut a long story short, what we found was that in that very first level that we cut, only 2 patients had granulomas in only that level. But they had granulomas in other levels from other biopsy parts. So by dropping that first level, the diagnosis was not affected, and we made a decision, therefore, to delete the first level from the protocol. The first level was therefore not put on a slide. We cut through that, and we only went from the second level onwards. And what we ended up doing, therefore, was we reduced our slides to cut, and this is now going back a few years, but it's even more effective now because our numbers are higher. But we reduced our slides to cut from just over 43,000 to just under 37,000, and the slides to examine went from around 22,000 to around 15,000. And by our estimation, that saved at least the pathologist 4 hours per week in examination of slides. So a really good example of how just cutting one level, one slide out of the protocol can save you a lot of time, energy, and resources. Again, small change, big impact. So just to remind you, the molecular assay was a good example of a defect and how we overcame that with a very small change. Autopsy reporting and the waste of waiting and how we overcame that with just one principle, that is making the cases more visible. And the GI biopsy slides and the waste of over-processing and how we overcame that by just dropping one slide. So I think you can see that if you apply lean principles properly and judiciously, you can certainly help find efficiency in healthcare. And don't lose sight of the reason that you're looking for efficiency in the first place, and that's improvement of patient care. So I want you to walk away from this talk looking for areas of improvement in your laboratory. What waste bucket's being filled? You know, look around. Is it waiting? Is it over-processing? Is it movement? And remember that small changes can certainly have a big impact on service delivery and patient care. Thank you very much.
Thank you, Gino. Thanks for that great presentation. If there are any questions, please type them into Q&A box. I can see here a comment, a nice talk from one of the attendees. I will have a question. When you went to this from 3 to 2 levels on GI biopsy, did you see increase in the number of levels ordered by the pathologist?
No, actually, it's a good question, Anna. We got a little bit of pushback from some of the, in fact, one of the GI pathologists saying that we may well miss granulomas, but we never did. And given that our GI biopsies are now over 10,000 parts a year, in fact, that very same pathologist came up to me not that long ago and said, thank goodness we're not cutting 3 levels anymore. So we've not had any issues. The pathologist is more than happy, more than welcome to cut extra levels if he or she wishes, but we've not seen that happen. So it's still been a sustained change.
Because sometimes, you know, with the polyps and all that, people do cut deeper levels, quite a number of biopsies to prove that there is no polyp, if the polyp is submitted by the clinician. Well, I see a lot of the comments that that's a great talk, and thank you. If there are no other questions, you can continue typing your questions for Gino. If I hope he will stay with us. If not, then I will forward to Gino all the questions that will be typed in the chat box, and I don't see questions for now.
A question that came into the Q&A?
Yep.
Okay, perfect.
I can imagine that there might be challenges obtaining buy-in for some lean changes processes, i.e. public-facing autopsy status list. What did you do to manage that within your department? Are there lean principles that speak to people management?
That's a great question, Anthea. And I think that we approached it from the point of view. I'm just going to mute myself because my phone's ringing. Hang on a sec. We approached it from the point of view of the public autopsy table or whiteboard was not there to be punitive. It was really there to help people keep track of their autopsies. And in fact, when autopsies went into the red, we actively sought what the barriers were and how we could help these people sign out their cases within a reasonable period of time. So it was all done in a very collegial way, and shifting it from the office whiteboard to the conference room whiteboard was actually a good thing too, because it was just within then our autopsy group and people had gotten used to the fact of prioritizing. But we really, the reason we did that in the first place was just to change the culture that autopsies are a priority, and nobody likes to see a red dot next to their name. It's human nature. I certainly didn't want to be top of that list. So it really did help change the culture, and people were receptive to it. There was some pushback. There was some issues with that in the first place, but it was met, as I said, with collegiality and in a spirit of helping. Your second question, does lean help with people management? No. Remember, lean is a system for finding efficiencies, and it was originally designed for car manufacturing. So it's not something that helps you. It gives you the tools to change, but it doesn't help you with change management. That's a really good distinction. And you kind of need those skills too.
Thank you, Gino. There is another question. How many levels do you think can ideally be on one slide?
Well, every institution is different. And for us, what we used to do was we would cut serial sections, let's say 6 serials on one slide, cut 20 microns, another set of serials, 20 microns again, and another set of serials. Where I came from in Melbourne, we would put, in fact, 2 levels on one slide. So we had 2 slides with 4 levels, but then you don't get as many looks at that one level. So it's variable. And I think it's really up to your own practice. We get a lot of IBD, we get a lot of Crohn's and UC. So it really helped us decide in pediatrics, okay, we really only need to look at 2 slides, not 3. But hey, if you want to put more levels on one slide, that's great, because again, you're saving the amount of slides, storage space, all that stuff that goes with that. What is the recommendation as per CAP and CAP ACP for the ideal number of levels for GI biopsies?
Yeah.
It was really hard to find that, and that we published this data in our pediatric developmental pathology journal. At the time, and I've not kept up with this, but at the time, there was no specific number of levels that were recommended, at least to my knowledge. I might be wrong. It might have come out in the meantime.
Thank you, Gino, very much. I think in the interest of time, we will have to go to next presentation. Thanks a lot again. And thanks for all the work you've done. And I can see it added a lot of gray hair to you that I can see. So it must be not easy as you presented.
Thanks, Anna. No, it's been a journey, that's for sure. Thank you very much.
Thank you. So I'll ask Andrea Green to introduce our next presenter, and really I'm looking forward to that lecture.
Yeah, it's a pleasure to welcome Dr. Prameet Sheth today to the meeting. Dr. Sheth is a clinical microbiologist and director of molecular microbiology at Kingston Health Sciences Center. He's also an assistant professor at Queen's University and runs a successful research lab. In the early days of the pandemic, Prameet and his team did an amazing job getting COVID testing up and running in our region. And he now oversees COVID testing for several hospitals in our area. He's also on the provincial COVID-19 technical group. So today, Prameet will be speaking to us about challenging myths during a pandemic, and we look forward to his talk. Thank you.
Thank you very much for that lovely introduction. I hope everyone can see my slides. Again, thank you very much for inviting me to give this talk. It's unfortunate I can't be there in person, but I have to say I had a lot of fun with this talk. One of the things that SARS coronavirus 2, and I'm going to call it that partly because I'm speaking about the virus and not the disease, is it's really brought about a lot of myths. So just want to say no conflicts of interest. And what I'm going to do is kind of give you a brief overview of the viral properties of the virus. And we really need this part to understand where a lot of the myths may or may not originate. And then what I did was chose two big ones. One is mode of transmission, and I understand this is a very deep water to tread, partly because things are changing on a daily basis. But hopefully I'm going to convince you of whether it's droplet, airborne, or fomite, and what the importance of each of these mechanisms is in the transmission. And then the second one is something that we always worry about, and that's viral mutation. And with the general interest and the public health interest of a vaccine, you know, the ideas around viral mutation are going to become very, very important, but also kind of surface and bubble right up to the top. As I was presenting, I was making this talk and I was finishing up my slides last night, a massive paper on viral mutation came out, and I thought, wow, okay, I'm clearly speaking about something that that's on people's minds. So one of the first things I did when I started thinking about this talk was, what and how do we propagate these myths, whether they're in medicine or outside? And it seems to be ingrained within our nature to kind of propagate them if they seem to somehow further a bias, whether it's selective or personal. So, you know, everyone says people should drink at least 8 glasses of water a day. And really, this comes from a really old recommendation stating that adults should drink about 2.5 liters of water. But what most people don't realize is the recommendation goes on to say most of this quantity is contained in prepared foods. So you don't actually need to go out and monitor 8 glasses of water a day. I mean, more water is probably not a bad thing, but it's interesting how that's kind of come about and become kind of dogma within our environment. You know, shaving hair causes it to grow back faster, darker, coarser. That's not true at all. I mean, they did a clinical study in the 20s that actually showed no effect, and yet that still is propagated. And then the third type of myth, and I think this is probably the one that we have to worry about the most, is the one that's entrenched with some level of scientific individual or study that provides the public with a great deal of confidence. And I always bring up Kary Mullis. So Kary Mullis was a chemist that actually discovered PCR. He was given the Nobel Prize in Chemistry in 1993. And until the day he died, he did not believe that the HIV virus caused AIDS. And that's something that you hear about. And we largely in medicine discount it because there's absolutely tons and tons of information and knowledge to say that the virus is actually the cause of the immune deficiency that we call AIDS clinically. However, because of this individual that had a lot of, how do I say, scientific credential, it propagates. Now, COVID obviously is absolutely no stranger to myths. I like the one from The Onion saying that the virus may use a propeller hat to stay airborne. That actually came out, and I think I laughed about it for 3 days. But in addition to that, we've got people pushing for things like herd immunity, or we've got members of the US government that are talking about the virus being a hoax, that are actually working with major public health figures like Tony Fauci. We've got people that are pushing an agenda with drugs that have absolutely no proof or no clinical standpoint as for use, and yet they're being pushed further, and this myth continues to propagate. So before we get into some of the myths, I just thought I'd introduce you to SARS coronavirus 2. So in general, coronaviruses make up a large family, and typically they come, or sorry, their sources typically tend to be other mammals, whether they're bats, camels, pangolins, and humans. And really, for most of them, they cause flu-like symptoms that manifest as an upper respiratory tract infection. And most of them are seasonal, and they circulate seasonally every year, kind of around the time that flu does. And we consider them the common cold. So not ones that are clinically, at least, associated with a great deal of mortality. However, that changes and has changed over the last few years. So, 229E, NL63, OC43, these are coronaviruses that your homegrown microbiologist will be familiar with, but most people don't really pay attention to them. Again, they're associated with annual outbreaks. They don't have huge infection control implications or public health interventions that are required, partly because they tend not to be ones that lead to a great deal of mortality. Now, obviously that's changed in the last 6 to 8 months, but the beta coronaviruses that make up a family of MERS, which is the Middle Eastern Respiratory Syndrome virus, SARS, the original one, and then now SARS-CoV-2, these are the ones that have been associated with major global outbreaks and significant mortality rates attributed to each one of them. None of them, obviously, anywhere close to SARS coronavirus 2. So one of the things about viruses is really their envelopes and their structure tell us a great deal. Typically, a non-enveloped virus, and we're talking about heavyweight viruses that transmit and lead to massive outbreaks in cruise ships, even when sanitation practices are followed. We think about norovirus, we think about hepatitis A that is stable in ice or at high temperatures. All of these tend to be non-enveloped, and they tend to be environmentally stable for prolonged periods of time. When you think about enveloped viruses, we think about things like HIV, hepatitis B, influenza. Yes, they transmit, and yes, they're stable, but quite practically, the envelope is not meant to be environmentally stable, partly because as the virus is budding off our cells, it actually pinches off a part of the cellular membrane to form that envelope. And our cells are not meant to be lying on inanimate objects for long periods of time and continue to be patent. And so when you think about environmental stability, we know that the environmental stability of enveloped viruses tend to be short. So minutes to hours at the very maximum, whereas non-enveloped viruses are exceptionally stable. So what does this have to do with SARS-CoV-2? Well, this paper came out a few months ago, and what they talked about was the aerosolization ability and the surface stability of SARS coronavirus 2 compared to coronavirus 1. And what they did was they found that the virus was stable for prolonged periods of time on various different surfaces, including plastic, cardboard, and metal. What they did was they took the virus, they aerosolized the virus into what's known as a Goldberg drum. And this is a rotating drum that has a nebulizer that leads to the virus being aerosolized. It's got a very controlled airflow system. And as you can see, the airflow system is quite small. Most air goes into the drum, but very little of it comes out. And the one that does come out is actually used for sampling. Now, the temperature on this is controlled, and so is the humidity. And what they found was that they had prolonged periods of virus virus stability on things like plastic, copper, as well as cardboard. And when they talk about stability, we're talking about in the order of several hours to several days. And so this kind of brought out the idea that SARS-CoV-2 can actually persist on things like people's groceries. However, when we look at data from patients, and so this is probably one of the nicest studies that didn't get as much press, partly because it didn't lead to as much fear-mongering in my mind. But when you look at sampling the air as well as surfaces, as well as personal protective equipment in a patient's room, while the patient is in there. So this is a study that was published in JAMA, and what they did was they sampled the room of a patient with symptoms while the patient was actually in the room. And they sampled it at 2 different time points, and they moved the air samplers around the room. So A was right by the patient bed, B was kind of close to the anteroom of the patient, and then C was a little bit further away. And what they found was when they did do air sampling in a patient that was symptomatic while the patient was in the room, no virus could actually be recovered from the air. Now that's important because it talks about the potential for transmission that is aerosol related, and B, it talks about the fact that even in high viral loads, they weren't able to actually find virus. They were using PCR, so they were not using live virus in this situation. So PCR tends to be much more sensitive than virus culture. The second thing they did was they swabbed the patient's room all around the surfaces pre-cleaning as well as post-cleaning. And in the pre-cleaning, as you can see with the yellow dots, as expected, they found recoverable virus from the side tables. They found recoverable virus from the bed rails, as well as the chair and the commode. And we all know that one of the things that does happen with SARS-CoV-2 is actually shed at high levels in fecal matter. And so they were able to recover it pre-cleaning. However, when they did the same sampling post-cleaning, they found no recoverable virus using a PCR assay, showing that even our regular disinfection system actually works in reducing A, potential viral loads, and B, seems to disinfect the environment quite well. Now, why is this important? Well, the key difference is really about transmission. And droplets tend to kind of get exuded from the individual and then fall to the ground by about 5 to 6 feet. And that's for small droplets, 2 to 3 feet for large droplets. And so when we start talking about airborne versus droplet transmission, it actually has major implications for infection prevention and control within a hospital, as well as public health guidelines. The problem is with SARS-CoV-2, the politics seem to trump public health guidelines and seem to kind of take over in terms of what the messaging needs to be. So this was set out by the CDC earlier this week. And one of the things that it says that really alarmed everyone was that there's growing evidence that droplets and airborne particles can remain suspended in the air and be breathed in by others. Having said that, they did kind of have an undertone of caution saying majority of the transmission seems to be by large or small droplets or small particles, but having that in there means that now we have to employ a much stricter intervention. And we were all very dismayed when this actually came out. And then the day later, they said, oops, sorry, we actually posted that by mistake, and that there's very little evidence to suggest that it actually spreads through air and can travel beyond 6 feet. This was after the WHO intervened, and I guess asked for additional data that had changed CDC's mind from making it a droplet type virus to an airborne virus. So the question is, well, if it's not airborne, why does it continue to spread if it's primarily associated with droplet? So we know transmission dynamics. And one of the things that is quite clear from viruses like influenza and other respiratory viruses is from the time you get exposed to the time you become symptomatic tends to be fairly short. So 1 to 2 days in terms of influenza. And rhinovirus is a little bit longer, but not really. It's about the same. And it's interesting because we actually have a rhinovirus outbreak right now. And I'm a little bit perplexed because we have all of these interventions in play, including physical distancing from people. So clearly we're not doing something right if we have a rhinovirus outbreak in spite of doing all of these interventions. Now, we know that both of these viruses and the exposure time to the time that somebody presents with symptoms is quite short. And rhinovirus is quite unique because it lives in the same niche as SARS-CoV-2. It lives at the nasal tip. And part of that is because the viral stability is actually higher at 35 degrees centigrade than body temperature. And so the transmission would be similar for both of these viruses. Well, what happens with SARS-CoV-2, and we've learned this from epi data, is the period from the time of exposure to the virus to the time of symptom onset seems to be longer. And that might allow for this continued transmission. Interestingly, there was the first paper that came out in the New England about asymptomatic transmission and contact was a woman that actually traveled from China to Germany. And the authors reported that this woman, when she met with her German colleagues, actually had absolutely no symptoms. You know, just to show how poor the reporting's gotten, the authors of the paper actually never spoke to the patient directly. And the public health officials said, actually, no, we spoke to the patient and she was symptomatic when she was in Germany. So this is part of the issue with the reporting that's gone on, at least in the time of the pandemic, and the real importance of actually being right. Having said that, the New England has not changed or issued an editorial or an edited comment or a correction of that initial paper. So it still looks like that particular patient actually had an asymptomatic transmission occur when she was actually clearly symptomatic. So the second one, and I think this one is going to be one that's definitely up and coming, is viral mutations. And we worry about viruses and mutations because they often don't have a proofreading step in their nucleic acid conversion to protein. With SARS-CoV-2, that's a little bit different because it actually does have a fairly robust proofreading step. So this was an article that came out in the Washington Post saying coronavirus is not mutating rapidly, hope for a vaccine development. Wow, fantastic. And then in May, fast forward 2 months, and it says, study shows spike mutations of SARS-CoV-2, making it more transmittable and dangerous. The reality is that it's unlikely to be a vaccine. So the question is it really mutating or is it not? And the change actually happened as a result of this paper by Betty Korber. And Betty Korber is a HIV evolutionary person. So she's brought her understanding of mutations and mutation rates from HIV into SARS-CoV-2. And what they showed was that they saw a shift in viral strains with a mutation called D6104G. So this is a point mutation that occurs in the spike protein. And the spike protein is important because that's the target that's been associated with neutralizing / protective antibodies, at least in a monkey model, as well as in vitro. And we think some studies in convalescent plasma suggest that the spike protein antibodies are actually the ones that are doing some of the work. So the other thing that Betty Korber and them found was that higher viral loads were associated with this point mutation using a pseudovirus model. So essentially, the virus had mutated. It had led to this shift. The shift happened in a key component of the viral spike protein, which is important, and it potentially increased viral load, which means that the individual was more likely to transmit. So this was a study I was looking at last night. So this is a study that looks at just over 5,000 patients in Houston and showed that there was a lot of mutation occurring. They showed that when the virus first entered into Texas, the D614G variant accounted for about 70% of the viruses, and now it's almost 99% in the States. So clearly it's taken over. And now they're thinking that this particular virus, is a better transmitter, but also is going to lead to worse outcomes in patients. So I thought I would share some data. So we did a really small study in Eastern Ontario of patients that came in into our environment. We sampled 32 patients that were positive between March 18th and March 30th. And what we were looking for is looking for changes in the virus, but also looking for where did this virus come from? Could we actually use phylogenomics to look back at the source of this virus? Hugh Guan, who's a colleague and a friend of mine, works at KFLNA Public Health, which is our local health unit. We actually got Hugh to contact the patients and ask them about travel history. And what we did was we let the genomics guys and the public health guys be completely separate and blinded. And then what happened was once we had all the data, we told the public health guys where we think this virus had come from. And the public health guys said yes or no, depending on finding out where the patient had traveled to. And some of them, actually most of them, we were spot on. So what did we find? What we found was that even in early March, when this virus first entered our environment, 93% of all of our patients were infected with this point mutation variant. We did not experience what they saw in Houston, which again was the same time period. It was between March and May was their first look at the virus, and then June to August was their second look. So we already had this virus primarily across the board within Canada, at least in Eastern Ontario. We're now following up with Toronto Public Health, and we're sequencing some of their genomes in a partnership to try and figure out if this was actually what came to Canada or not. The two specimens that you see that don't have that green bar in there is where the point mutation didn't happen. And those are actually this specimen, which came directly from Wuhan. So this was a patient of ours that traveled directly from China to Kingston sometime in early March. Everything else was the B lineage, which already had the point mutation and came to us from either Europe, Australia, or parts of the United States. So essentially, it looks like there was one variant of the virus that circulated within China, and then shortly before or just after leaving China, it jumped, made this point mutation, and actually started spreading. But we don't have any evidence that it actually came to us as the original Wuhan strain and then mutated out. We think it was something that happened way before March 2020, and it's going to be really interesting. We've now expanded our sequencing to another 200 to 300 patients, and we're trying to look at viral evolution over time, at least within our environment. So just overall, higher rate of transmission than influenza, partly because of longer duration between exposure and symptom onset. The virus is primarily spread by large droplets, very different epidemiology if it were airborne. We found in our study, and some of the Toronto data corroborates this, is that the mutation was actually introduced into our setting much earlier than what they find in the States, and at a much higher proportion of patients with this virus. And we don't know if that virus has actually altered specific dynamics for transmission, and we certainly don't have data on morbidity and mortality. Just wanted to thank the numerous people that do all of this testing. I really do believe I stand on the shoulder of giants. The KHSE clinical microbiology team has been absolutely incredible through this entire pandemic. The picture on the right shows you what we processed yesterday alone, and clearly an undertaking that we've never had to actually do. Members of my lab for doing a lot of the sequencing and a lot of the grunt work. And then, of course, collaborators without whom I would not be able to decipher all the genomics. Thank you very much.
Thank you very much, Prameet. That was really an excellent talk. I mean, so much has changed so quickly, and I don't know about everyone else, but I'm glad not to be washing my groceries anymore. So I think we have few minutes for questions. If anyone has any questions, they can type them in the chat or the Q&A. I see a comment that it was a very great talk. Thank you.
Oh, thank you.
Often takes a few minutes for things to come through. Okay, I have one question coming in. What are your thoughts on the vaccine?
Yeah, that's a really, really good point and a great question. I mean, you know, when I first started putting this talk together, I thought about, okay, I'm going to work on transmission. I'm going to work on immunity, and then I'm going to work on the virus. And then I was 58 slides in and I said, well, no, you can't work on immunity. There's a huge number of questions still pending. I mean, I think the vaccine is imminent, and we don't know about timelines, partly because of the regulatory. I think the next hurdle is, how do we mass produce this at a global scale? What we don't have a good sense of is how long that immunity is going to last. When we talk about other coronaviruses like OC43, which commonly circulates, you know, one of the issues with these other coronaviruses is the immunity is fairly short-lived. So we're talking about between 35 and 42 weeks. So if you think about, you know, how we're going to roll this vaccine out, is it going to become like an annual flu vaccine kind of thing? What are we going to need there? There's already a couple of stories, and again, these are case reports coming out of Nevada and out of India, actually, of reinfections, where a person was infected early in the pandemic and then now has managed to get reinfected despite forming immune responses. And then the third component, which we know the correlate of protection in animal models, in vitro, as well as in monkey models, but we still do not have a correlate of protection in humans. So we don't know what antibody is actually neutralizing for the virus and actually leads to protection.
Yeah. Yeah, we have a few more questions coming in. Maybe we have time for one more question. We have a question just wanting to clarify the method of transmission. Does airborne transmission still play a non-negligible role?
So great question and really important. Yes, the predominant method of transmission is still droplet. And that's one of the reasons why face masks work so well, because those face masks actually trap the droplets in your mask and don't have you exuding them. And you know, in the beginning of the pandemic, people were saying, well, face masks don't make much of a difference. And they're right, because they don't actually protect you from acquiring the virus. They protect you from not shedding the virus. And so when you go to a population level, face masks are exceptionally efficient. But on an individual level, without everybody else being masked, they provide little, if any, protection.
Yeah, thanks. Well, thank you again, Prameet. That was an excellent talk. I think there's a few more questions, but we'll try and get those to you, and maybe we can get them answered separately. And I think for the sake of time, we need to move on to the next presentation. So thanks again.
Thank you very much. That was an outstanding presentation. Just want to remind everyone to fill out the evaluation forms that you got yesterday, and you will get them today again with regards to all the speakers. And I'll ask Corwin to introduce our next speakers, please.
I'm delighted to introduce our next two speakers. They both happen to be colleagues of mine, and just both fantastic people to work with. So first, Dr. Hasan Ghafar. Dr. Ghafar is an assistant professor at the University of Toronto, and also an investigator in the Lee Cushing Knowledge Institute, and the medical director of laboratory hematology at St. Michael's. And his main areas of interest include lymphoproliferative disorders and flow cytometry. And then Dr. Sasan Zandi, who is also a staff hematopathologist at St. Michael's Hospital and an assistant professor at the University of Toronto. And I'm going to go a little off script here because he's a humble guy, but a quick look at Google Scholar will reveal that he's also quite the prolific researcher. So I'm very much looking forward to your talk.
Thank you so much, Corwin, and thank you to the organizers for such an incredible program. I've certainly really enjoyed the talks yesterday and this afternoon. Just gonna share my screen here. Can everybody, I'm not sure if this is working.
Yep, it looks great and you sound great too.
Excellent. Thank you very much for confirming that. So the topic that I would like to present alongside my colleague, Dr. Zandi, is Hematopathology Conundrums, a toolkit for the perplexed pathologist. Neither Sasan or I have any conflicts of interest to disclose related to the content of this presentation. This, as you may be familiar with, is a painting by Munch, which to me accurately depicts the emotional response of some people when they encounter hematopathology, difficult hematopathology cases. And as Corwin mentioned, I'm in a position of luxury in some respects in that I practice exclusively within hematopathology, but I can't say that I don't sometimes have this sort of response. Everyone's sort of familiar with the late night, late Friday evening acute leukemia case, that sort of provokes some degree of anxiety. And to be honest, there are some aspects of hematopathology that are not entirely exclusive, but somewhat unique when compared with other areas of anatomic pathology. Not everyone is familiar and comfortable with the variety of different types of preparations used routinely in hematopathology, particularly Romanovsky type or Wright-Giemsa type.
Oh, Hasan?
Yeah.
Sorry to interrupt, but it doesn't seem like your slides are advancing.
Okay.
We haven't seen the painting.
Oh, okay. So let me try this again.
Yep, we see it now.
Okay.
Thanks.
So, okay. Can you see the next slide now?
Sure can.
Okay, great. Not everybody is similarly comfortable with the different types of preparations that are used routinely in hematopathology. In addition, in contrast to other areas in anatomic pathology, some hematopathology specimens have no gross correlation at all. Peripheral blood has really no anatomic kind of compartments to refer back to. And more commonly, we're seeing cases that require ancillary studies beyond just immunohistochemistry. Flow cytometry obviously is routinely employed. Cytogenetics is often essential, and next generation sequencing has been an emerging technology that has become very important in diagnostic hematopathology. And of course, we have these cases that show significant morphologic overlap. On the left, we have a case of hypogranular acute promyelocytic leukemia characterized by these bilobed or butterfly sort of nuclear configuration of the blast. And then on the right-hand side, we have a case that has some overlapping features in terms of displaying a component of blasts that are bilobed. And this turned out to be an acute myeloid leukemia with a nucleophosmin-1 or NPN1 mutation. The kind of key morphologic correlate here is the presence of these blasts with cup-shaped nuclear morphology, or so-called thumbprinting. And these can have an identical immunophenotype. In fact, this was a case that I suggested could be APL, and was sort of humbly, humbled by the fact that I was wrong, and it actually was AML with NPM1 mutation. So what I would like to do in this presentation is to apply a very basic approach to the diagnostic evaluation of hematopathology specimens. We're going to try to apply some simplified tools, so not, sort of high-level, high-tech, ancillary investigations, but really just going back to the information that would be commonly available to you, as a pathologist reviewing an abnormal peripheral blood film. And of course, the focus here is on morphology, with some discussion about the use of ancillary studies. We've all heard many times about the importance of applying a multifaceted approach in the diagnosis of hematological disorders, particularly malignant hematological diagnoses. And ultimately, hopefully, these will help to reduce some of the anxiety that occurs when one encounters these types of cases. So again, the diagnosis of hematological disorders is one that requires a multifaceted approach. As pathologists, the primary anchor for the diagnosis, however, is the morphology. And when I was in training, I was always under the impression that hematopathology would be made a little bit easier, knowing that so many different ancillary tools are available to come to a definitive diagnosis. But of course, it's not uncommon that all of those facets kind of lead in different directions, and we end up with a sort of a, having to make a kind of a decision based on kind of where the needle points when we add up all these various facets, emphasizing that it's really important to select ancillary studies judiciously, and always consider, if what one would decide if the investigation comes back contrary to the initial diagnostic suspicion. And this is just a diagram illustrating the types of tools which are sort of low-tech but can really help one narrow down a differential diagnosis. And this approach is readily applied to peripheral blood film morphology. I think it's important to use the CBC as a roadmap. Don't just look at the slide without having any information with regard to the CBC. And one can formulate a pretty good differential diagnosis just from looking at the CBC, and then think for a few minutes. How would you narrow the differential diagnosis based on what you see on the peripheral blood film? Applying this approach rather than just throwing the blood film down and going to high power, I find to be much more informative. If you have some clinical information, and it's not always that we would have them, particularly if a patient's in emerge, You know, you may not have a note or you know, some really detailed documentation to correlate your morphology with. But if you have some information, then it's good. Sometimes that clinical information could come from the history provided on a chest X-ray. You know, any information that's there could potentially be useful. It's a good idea to scan the smear at low power and look for an optimal area before going on to high power. As Sasan will discuss, if we're in the thin area of the slide, you will see artifacts like spherocytes that are not really present. If you're in the thick part of the smear, you may see different kinds of artifacts like rouleau. It's useful to evaluate trends using previous CBC data. If a patient's hemoglobin drops within a day or two, that's obviously different than a situation where they've been anemic for many months or years. And then when you're looking at the blood film, ideally the technical staff who have referred it to you would have noted any causes of spurious counts like platelet clumps. But it's a good idea just to kind of, just for a few seconds, to think, to consider of whether there could be some spurious counts, and look for things like platelet satellitism causing artifactual thrombocytopenia or platelet clumping. So just to show you how this concept could be applied, this is a CBC from a 55-year-old female, pretty typical kind of case that would come through, at least in our lab. And as we can see from the CBC, the patient has a normocytic anemia with a hemoglobin of 95 grams per liter and a platelet count of 20, so a marked thrombocytopenia. Reticulocytes are 145, so there's a good marrow response to the peripheral anemia, and the white count and differential are unremarkable. So before looking at the peripheral blood film, one might want to just sort of consider a differential diagnosis, not one that has to be exhaustive and comprehensive, but one that at least touches on the most relevant kind of time-sensitive diagnoses. And for me, with normocytic anemia and thrombocytopenia, I think of this particular list: HUS, TTP, DIC in a pregnant patient, one would consider HELP syndrome, and then Evans syndrome, autoimmune hemolytic anemia, and ITP. And so now I can sort of approach the peripheral blood film with a bit more information and a little bit more confidence. So in the list of conditions, all except for Evans syndrome are types of microangiopathic hemolytic anemia, where one would expect to see fragments, red cell fragments or schistocytes, as red cells are impaled upon fibrin strands in the circulation. And indeed here we have a number of fragments. Here, this one's sort of triangle shaped with angulated edges. We don't see other, we don't see findings, red cell findings that point towards other types of hemolysis like bite cells, which would be expected in oxidative hemolysis, or spherocytes that might be seen in an autoimmune type of hemolysis. And of course, we confirm that the thrombocytopenia is real. We see very few platelets in this particular field, no evidence of platelet clumps. And then if you can find any additional information, particularly relevant would be hemolytic lab results, such as LDH, which in this case is increased bilirubin. And we see here that there's an increase in indirect bilirubin and a decrease in haptoglobin. AST and ALT were within normal limits. If there was evidence of liver function abnormalities, and one might consider that the hemolytic labs could be skewed, and it could appear that there's hemolysis biochemically when actually those results could be due to liver disease. And importantly, the direct Coombs was negative, excluding an immune-mediated hemolysis. And then later on, usually, within some hours or perhaps the next day, we would have the results of ADAM-TS13, which in this case showed severe deficiency, everything pointing to the diagnosis of TTP. So with that, I'm going to turn it over to Dr. Zandi.
Hello, everyone. Good afternoon. Just a quick thank you to the OAP organizers and Corbin for the invitation. I'm just going to jump right in. If you can confirm that you can hear me and the slide advancing, that would be great. Okay, so Dr. Ghafar gave a fantastic introduction to the approach to the blood film, and I think I can only cover the blood film here and not the bone marrow biopsy. Hopefully I can get through at least the red blood cell components. And what I would like you to take from this talk at the minimum is to have a systematic approach to the blood film, and that save you a lot of time and prevent missing pretty much anything on the peripheral blood. Peripheral blood can be very easy if you approach it systematically, and can be very complicated. As Dr. Ghafar mentioned, if you take the film and start using 40x power and go around, you probably miss a few things after seeing a few peripheral bloods. So what I would like to do is actually, before going to look at the morphology on this slide, is to look at the CBC and highlight a few things. Number one is the CBC, also the age of the patient, the gender of the patients. Those are the information that can help you to interpret the blood film later on. And as Dr. Ghafar mentioned, by then you already form a differential diagnosis in your mind that helps you to identify or to diagnose if there's any abnormalities. Coming to the blood, to the actual film and examining the morphology, I'm sure you heard this and you know this, but don't forget to look at the low power on the slide edges and on the feather edge, because large things tend to float on the peripheries. So if you don't look at the edges, you might miss things like blasts, parasites, megakaryocytes. I'm sorry for the overhead. So make sure that you look at the slide edges and the feather edge. Look for those things. It takes a few seconds to do that. And then try to be very organized approaching the blood film. Go from red cell, white cells, and platelets. For the red cell, look first at the distribution of the red cells, then look at the morphology, then think about if there is any inclusion in the red cell, and then the same thing for the white cells, the distribution of the white cells, morphology, if there is any inclusion in the white cells. And platelets are pretty much is very simple, and hopefully we can come to that in more detail. So I know that you all know this, but very, very quickly, take a look at the cells that you can see in the peripheral blood. Obviously neutrophils, lymphocytes, red cells, platelets, basophil, eosinophils, and and monocytes. I'm not going to explain the morphology of them. You all already know. But there are also other things that might come to the peripheral blood and that can have very important diagnostic value. So, for example, nucleated red cells, you can see them. It's not uncommon to see them in the peripheral blood. Plasma cells, these two might be confused sometimes. There are features that can help you to differentiate them. NRBCs tend to have a very round nucleus, pycnotic, like an ink that you put on this slide, whereas the plasma cells have a more open chromatin. In terms of cytoplasm, the NRBCs have more gray cytoplasm, whereas plasma cells are blue, and also having a perinuclear HOF is helpful in identifying plasma cells. Then you have the reactive lymphocytes. I will go into more detail later. This is sometimes causing problem for the person who reviewed the blood film. Can be mistaken with blast cells, particularly in children and newborns. Then there are like rare cells that can make their way into the blood, like mast cells, blasts, you will see them, and extremely rarely non-hematopoietic cells like carcinoma can also be seen in the peripheral blood, particularly at the feather edge and the peripheries. So let's just start with the red cells. So in the red cells, as we said, we look at the distribution, the size of the cells, morphology, and any inclusion. And that's all you need to do to evaluate the red cells. So there are essentially two things in the red cell distribution. So one, you might see this, so agglutination on the peripheral blood film. And when you see this, you have three things in your mind, like three differential diagnoses basically that you need to clear. And you can help the clinicians by your finding in the peripheral blood. So number one, is this a technical issue? Number two, if it's not a technical issue, this could be a cold agglutinin. And the differential diagnosis for cold agglutinin is infection, inflammation, and neoplasm. So the part that you can help is to look for the possible lymphoproliferative disorders. For example, if there is a CLL already on the peripheral blood and on the smear that you can report. So those are the things that you can do. Other than that, you can just report the agglutination and leave it to the clinician to work up the cause. The second abnormality in distribution of red cell is rouleau formation. So the only pitfall with the rouleau is that you have to be careful where to look for the rouleau. If you go deep to the slide, particularly the slides that are manually made, everything looks like a rouleau, and everyone has a rouleau. But if you find, so if the slides are manually made, there's only a narrow part of this slide, a small part of this slide that are actually useful for morphology. And if you do see more than 4 to 5 red cells stacking up, that is the rouleau. You can also look at the background. So typically in these cases, which you have hypergammaglobulinemia, you have a blue background on your slides, can be visible even without in the macro examination. And that you can just report as rouleau, consider hypergammaglobulinemia, and you don't need to go further than that. The only thing that you need to look for a little bit more carefully when you see the rouleau is the presence of plasma cells in the film. That can have an important diagnostic implication. So those are the two distribution. Let's go for talk about the size. Basically, there is two. Again, there's two possibilities here. You either have microcytosis or macrocytosis. And for both, you have a list of differential diagnoses already. And, for the most part, I don't really try to gauge the size of the red cells by morphology. You can very simply look at your MCV in the CBC report for the size of the red cells. And there you have only, there is a long list of differential diagnoses, good for the Royal College exam, but practically you're basically facing with 3 differential diagnoses that you can figure out. One is iron deficiency, anemia of chronic disease, and thalassemia. There are features in the peripheral blood that can help you to decipher those, but these are the 3 differentials that you can benefit from looking at other ancillary testing and your CBC. For microcytosis, if you want to decipher these 3 entities or differentiate them, you can simply look at if there is a ferritin available. The ferritin is low, is more likely iron deficiency. If it's thalassemia, they tend to have iron overload with high ferritin. The other useful feature is the trend of the MCV, as Dr. Ghafar alluded to as well. So if you look at somebody and you can go back in time and look at the MCV, and they have an MCV of 60 for as long as you can go back, that's more like a thalassemia. Whereas if the MCV has been normal and all of a sudden you have abnormal low MCV, this tend to be more supportive of iron deficiency. And if you look at the history, if there's a history of lupus, RA, and other autoimmune disorders, then or even malignancy, anemia of chronic disease is more appropriate. For example, this is not a picture that you commonly see, particularly in Canada, but if you have a microcytic anemia and then you see this NRBCs, basophilic stippling, and high ferritin, this is more in keeping with thalassemia. You might see these cases in new immigrants to Canada, and they come do their first CBC. You might be actually see this picture, but it's extremely rare. So iron deficiency can be a bit scary looking on the peripheral blood, particularly the chronic ones. You can actually have quite a lot of red cell abnormality on a blood film from iron deficiency. You can see target cells, you can see hypochromasia, you can see poikilocytosis and anisocytosis. So this poikilocytosis picture can be seen in iron deficiency. And again, the way to really figure this out is by looking at other parameters, including ferritin and the trend for the MCV in these patients. So that's microcytic anemia, very simple. So basically you need to think about 3 things, 3 common things. Of course, lead poisoning and hereditary sideroblastic anemia are part of the differential, but they are not very common at all. So we already talked about differentiating thalassemia versus iron deficiency on the peripheral blood film. And let's talk about macrocytosis. Macrocytosis can be with anemia or without anemia. And there are very few features in the peripheral blood film that can lead you to a particular diagnosis. The differential diagnoses that come to mind, and again, you already have it when you look at the CBC. So differential is a little bit broader than microcytosis, and that includes B12 folate deficiency. You think about that. You think about MDS. You think about liver disease, alcohol, medications, and hypothyroidism. These are the most common ones. So what you can do by looking at the peripheral blood is actually to pinpoint 2 of them. If you do see hypersegmented neutrophils, for example, and that defined as a neutrophil with more than equal or more than 6 lobes, that points toward this being a B12 deficiency. Folate deficiency, as you know, it's very rare because of the fortified bread in Canada. The other thing that you can find out and that led to a diagnosis is the opposite. So if you have neutrophils with low segmentation or pelgeroid, which define as 1 or 2 lobes basically, or if you have a hypogranular neutrophils, and basically hypogranular neutrophils are the ones that has no no granules, the cytoplasm is pretty much the same as the background. Or if you have blast floating around, that points you toward this being an MDS. Obviously, looking at the age can be helpful. MDS is mostly in the elderly. It can be a very important finding. I can tell you in St. Mike, we have a big portion of the MDS are being diagnosed and worked up based on the peripheral blood. So we report the possibility of MDS, and then they go on to a bone marrow biopsy to confirm. So it's important to pay attention and keep that in mind, particularly in elderlies. For the rest of the differentials, you have to go back and look at the history of alcohol use, if there is any increase in liver enzymes, if there is low TSH, or some medications like hydroxyurea and chemotherapy can give you the macrocytic picture. So very simple. So we know what to do with the microcytosis and macrocytosis, how to report it. Let's talk about the morphology. So, and we talk about, so we can start with the red cell morphology. So this is not a typical morphology that you see. Well, let's just start with the spherocytes. This is a hereditary spherocytosis. Probably we don't see it. These patients typically been investigated at sick kid and earlier stage and being treated. What we see quite often actually is acquired spherocytosis. Again, there's a large list of differential diagnosis, which is good for the exams like drowning, snake venom bite, that kind of things, burn. But really it comes down to hemolysis. There is one entity that you have to be able to work up, and that's the possibility of hemolysis. And it happens particularly in the hospital, you do tend to see more of that because people get transfused. So transfusion can cause hemolysis. They have autoimmune diseases that can cause this. So paying attention and identify these spherocytes is important. And they are never like this, like everything is spherocytes. I'm showing it just to point out how they look, the absence of central pallor, but typically they are a few in the peripheral blood. This is another extreme example of autoimmune hemolysis. So this is the point that the bone marrow is responding. Now you can see the NRBCs, you can see the spherocytes, fragments, polychromasia. That's the sign of bone marrow trying to compensate for the peripheral hemolysis. Again, this is not a very typical picture, but an extreme picture. And it's important because sometimes you are the one who actually suggested the hemolysis, and then the rest of the investigation comes after that. You can also look at other parameters in the lab, and other lab parameters, like if there is any increase in bilirubin, for example, indirect bilirubin, if there's a haptoglobin that is low, if there's a DAT that is positive. These are all confirming your findings and the presence of hemolysis. So that's a spherocytosis. This picture you are all familiar. This is what we are all worried about, and Dr. Ghafar also had a slide of it. So the presence of fragments, very important to pick up. This is typically the very first sign, and that led to the initial diagnosis of thrombotic microangiopathic disease. The presence of these schistocytes, typically it should be more than 1%, but if there is a thrombocytopenia present at the same time, you can actually report it as many schistocytes as you see. All right, so this is actually a very simple thing. So I think all of you already guess what it is. It's a sickle cell disease. The reason I brought it up is because there are some uncommon variation of sickle cell. For example, if you have a SC patients, they might present as OAT and BOAT cells, which are not as sharp and nice sickling disease as you see in the homozygous SS. So you need to be aware of that, OAT and both cells. Otherwise, there's only one entity that can present like this. So the other common morphological abnormality you see in the red cells is this acanthocytes. So acanthocytes, sometimes you see them together with Howell-Jolly bodies. And again, there's very limited differential for this entity. When you see them, you think about essentially a few things. This could be number one, a person with a splenectomy or hyposplenism, that they can't get rid of all these acanthocytes and Howell-Jollies. The other thing is the history of alcohol use, liver disease. Those are the three main things. There are other things that we never report, but again, listed as differential, for example, McClaw syndrome and other things. But essentially, those three are the main differentials for acanthocytes in the peripheral blood. All right, so this is another abnormality you see. These are more regular, jaggedy appearance of red cells. And again, the differential diagnosis for this is very short and simple, thinking about the common causes of echinocytes. So these are actually echinocytes. So basically, number one cause could be hydration effects. Basically, if you have water in your fixation, this is an artifact. Or this could be liver disease or renal failure. So uremia can give you this picture, but in this day and age, most people getting dialysis, and you don't really see that much of this picture in the renal failure patients. But liver disease and artifact remains the top differential for this picture. All right. So the next entity I'm talking about is, again, this is in the order of being common. This is another abnormality that you can see in red cell morphology, and that's seeing these blister cells. Basically, you can see the hemoglobin is concentrated in one side. So you see these blister cells and also these irregularly contracted cells. This is the picture that you mostly see in oxidative stress or oxidative hemolysis, G6PD patients that came to the emerge, got Lasix or Raspberry case, and now they are hemolysing. And you see this picture that can be very helpful if you can identify it. All right. So again, this is another common finding in the peripheral blood, especially if you are working in a hospital setting. These teardrops, if these teardrops, you see them together with nucleated red cells and a left shift, that gives you the leukoerythroblastic picture. That, again, there is a long differential diagnosis attached to them, but basically from the peripheral blood point of view, it's just myelophthisic. You can just report it as considered myelophthisic syndrome. That can be myeloproliferative disease or can be a metastasis to the bone marrow with fibrosis. Okay. All right, so I think we still have time, yes. So WBC, again, I want to have it very simple approach to the white cell morphology in the peripheral blood. So basically, again, start from the CBC. You either have the numbers up or you have the numbers down. So you're either dealing with proliferation of a lineage or you're dealing with cytopenia in the CBC. So you are already kind of thinking your differential diagnosis from the CBC. But then there are occasions that you can see abnormal cells in the peripheral blood. It could be blasts, left shift, or atypical or reactive lymphocyte. So let's start with this, one of the most common pictures that you see in the hospital setting. So you have seen this many times, I'm sure. toxic granulation, and sometimes you see these doughy bodies in the neutrophils. And now we are talking about the neutrophils and the neutrophil inclusion. So the two main differential diagnoses when you see toxic granulation, two things. One is, everyone think about sepsis. The other thing that has to be kept in mind is the GCSF use, or particularly in the cancer patients. So very often, even for breast cancers, they use GCSF, and you might see this toxic granulation with dull bodies, even some dysplastic cells or blasts floating in the peripheral blood. So it's important to note that, and when you report it, you just say that history of GCSF treatment been noted. Okay. Eosinophilia. So this is one of the most difficult ones because the differential diagnosis is broad and it's very hard to pinpoint by morphology and even other lab tests the cause of eosinophilia. In the hospital, the eosinophilia is most of the time is drug induced. So it's the new medication that they started, and after that you have this eosinophilia. Just take a look at the new medications and you can comment on that. That might help the clinician to work up the eosinophilia. Other than that, there's not much, unless you see a blast in conjunction with the eosinophilia or other lymphoproliferative disorders that you can see on the peripheral blood. There's not much that can be reported on the eosinophilia. They are reactive, and they can be reactive to all sorts of things: infection, inflammation, neoplasia. So the differential diagnosis is very broad. Okay, so this is another very typical picture that you can see more than 2-3 of them per day even. Very typical picture. You can see the, so now we are in the lymphocyte realm, the smudge cells and the very typical soccer ball mature chromatin of lymphocytes. The only point I want to make here is that the smudge cell is not equal to CLL. Smudge cells can be seen in ALL, it can be seen in other leukemias, it can be seen in other entities. So a smudge cell by itself is not a diagnostic even clue for the CLL. You really need to identify the atypical lymphocytes there. All right, so this is another area that can cause trouble for even experts, and that's reactive lymphocytes. So reactive lymphocytes can look very scary, especially if you have seen the reactive lymphocytes in a young person, like in this case is a 20-year-old female with the high fever and lymphadenopathy coming to the ER. You get this blood. If you don't look at the age or look at the history, it can be hard, and you might think about this could be a blast, but differentiating blast and reactive lymphocytes can be difficult. But if you focus on the nucleus only and just forget about the cytoplasm, because they can vary a lot. Sometimes even they have granules in them. The nucleus is actually what helps you to identify them and differentiate them with the blast. So blasts tend to have a very fine, smooth chromatin, whereas reactive lymphocytes might have a lacy chromatin or more condensed chromatin. And also the history is very important. So if you see these together with thrombocytopenia, that might be a different story. The other thing that can help is to continue looking at the slides and comparing the cells. Reactive lymphocytes tend to be a little bit different in morphology. They are more pleomorphic, and those are the hints that you can get to differentiate them. Be particularly cautious when you do see these cells in newborns. Some hospitals might have a newborn ward, and we have one case last month that has been reported 40% blast. When we looked at it and reviewed it, it was actually baby lymphs, which might look scary. Again, you can get help from the history. For example, if this is a newborn with Down syndrome, then that could be actually a clue that this might be leading you to having a blast, a real blast in the periphery. Okay. So these are the blasts that we already talked about. They come in various shapes and forms. So there is no single definition for the blasts. So they might have nucleoli, they might not have nucleoli. The cytoplasm could be granular, could be without any granules. So it's the only unifying feature for the blast or the chromatin, the fine chromatin in the blast. And then you can get help from other parameters, like if it's in conjunction with thrombocytopenia and abnormal PT-PTT, the patient is in DIC, that can help you also to form your accurate differential diagnosis. Okay. This is a typical picture that you, during your training, I'm sure many times you talked about it. The second thing that should not be missed in the peripheral blood, and that's APL. So you can see in several forms. This is the classic APL with multiple hour rods, thick hour rods in the blast. So what to keep in mind is that if you see blasts, go through as many blasts as you can, because only one of them might show you this hour rods, and that can be very helpful diagnostically for the patient. If you're suspicious of APL, just say that you're suspicious APL. If it's wrong, that's fine. The opposite it can be more problematic. Dr. Ghafar talked about it, so they can come in like a Venn diagram or binucleated. They can be hypogranular or agranular, so it comes in different forms. Okay. Platelets, those are probably the easiest of all in the peripheral blood. So basically, the only thing you can see is the number of platelets, up or down. Is there any platelet clumping, and the size of the platelet and granularity. So this is the platelet statolytism that can spuriously lower the platelet count. You can have platelet clumping, again, that interferes with your counts, so you have to pay attention to that. Other than that, you see this might be, so you look at the size of the platelet, so you have you might have large platelets, giant platelets in reactive or in cases that there is a peripheral destruction. Or you might see large platelets with hypogranularity. And that's an indication of possible MDS, which can give you a hint about MDS as well, together with other pancytopenias. So I'm gonna, so this is just an example of a giant platelet. So the definition of giant platelet is that the size of the platelet should be bigger than the RBC. And again, the granularity is important. And that's pretty much it for the platelets. And I'm gonna stop here. If there is any question, I'm happy to take.
Okay, well, thank you so much, both Drs. Ghafar and Zandi, for a very informative presentation. And we do have some questions for you. So let's start with this one. What is the cause of RBC fragmentation in warm autoimmune hemolytic anemia?
So Dr. Ghafar had a list of all the entities that you can see in the the fragmentation in warm autoimmune hemolytic. This is unlike TTP that they postulated that the cause of fragmentation in the MAHA is the formation of the fiber, the fibers that can shear the red cells. In warm autoimmune hemolytic anemia, it's not very well known, but could be partly because some of the cells escaping the spleen and then come out as fragments.
Another practical point is that sometimes in microangiopathic hemolytic anemias, there may be a component, usually a minor component of spherocytes, and that's thought to happen as the damaged red cells kind of try to reseal the membranes and they form spherocytes. So sometimes I get a phone call from a clinician saying, well, you reported fragments and spherocytes. What is it? Is it immune-mediated hemolysis or is it microangiopathic? And it can happen. And sometimes it's not a pure picture, but I try to sort of go with the most, I guess, what's the predominant pattern?
I can see another question. Carlo is saying, is there any, in the setting of thrombocytopenia, no clinical history, presumably no creatinine, is there a percentage of fragments at which point you're calling a clinician to raise TTP? I think 1% is reasonable. And if you don't have those features, it's very hard to say. I tend to just report them and mention that this is less than 1%. I don't know if Dr. Ghafar has any other.
Yeah, I think the rule of thumb is 1%. Fewer than 1% could be a non-specific finding. When I have residents rotate through, sometimes they make their own blood films and we look at them together and I tease them because I can always look really hard and find one fragment. It doesn't mean anything in the context of a normal CBC. On the other hand, we get patients, because we're a center for plasmapheresis, we get patients after they've had an initial presentation of TTP, they're taught to come right away to the hospital if they feel the slightest bit ill, if they have a headache or anything. So they show up to the emerge, they have an elevated LDH, an undetectable haptoglobin, maybe unconjugated bilirubin, and you don't find any fragments on their peripheral blood film. Or you very, very few, less than 1% fragments. And I've seen those cases as their picture evolves, as they become sort of more, the disease sort of declares itself, it might be useful in those instances to review serial blood films, just to see if you could see kind of that fragments kind of become more numerous as the disease evolves.
Okay, I think we've got time for just one more question. So what modality do you recommend to confirm APL, rapid FISH or PCR?
So in Toronto, and partly it's really what is available and what is turned around quickly, we send for PCR. We send for PCR. I don't know if that's sort of the practice in other kind of in other places. That question has come up with CML as well. So for BCR-ABL, in my training in the US, we were using FISH. And PCR can miss some cases. But in Toronto, because I guess PCR is so much more sort of widely available and we get a kind of very good turnaround time, we tend to use PCR for CML. And if there was a case where I thought it was CML and the PCR was negative, that would be a very rare situation. I would consider, you know, going with another technique such as fish to maybe kind of, you know, ensure that we haven't missed the rare case.
Okay, thank you very much. So we'll hand back over to Dr. Pluck.
I'm sorry, Dr. Plotkin, we can't hear you at the moment. I see you're off mute. I can't. That's okay. I'm happy to. My name is Meredith Slack, and I'm the conference manager. As Dr. Plotkin may connect, are you able to try one more time, or can you hear us, Dr. Plotkin? Okay. Perhaps there's a kink in the technology, which I'm so glad everyone's been on and able. We've had a great group of speakers today and also a great turnout. So I'd like to thank you. I'd also like to encourage everyone to stay on the line. We have only been able to weather this storm of not having an in-person conference through the support of obviously these wonderful faculty of speakers, but our sponsors as well. And we have a representative from our bronze sponsor, Amgen. Greg is on the line with us, Greg Jackson, and he has a short presentation for us all, and I'd hope that everyone stays on to hear all of the valuable things that Greg has to share with us. Greg, please go ahead.
Thank you very much, and thank you to the faculty and to everyone else to having us part of your wonderful conference. And hopefully next year we can do this all in person. But before I begin, just to confirm you can hear me and you can see my slides.
We can hear.
Absolutely, Greg. Yep, absolutely.
Excellent. So my name is Greg Jackson. I am a product manager here at Amgen Canada. I work in the colorectal cancer franchise. And really just over the next 5 minutes, just wanted to give you a high level overview of what Amgen Canada is doing here in the world of oncology and how it may overlap with some of the work you're doing in pathology and in biomarker research. So as you may or may not know, Amgen has its roots in California about 40 years ago. It's grown from a very small biotech company to one of the largest biotech companies in the world that is now has presence in over 100 countries and are many medicines, which most of which are biologics, have reached millions of patients worldwide. The mission at Amgen is quite simple. It's to serve patients. And during these troubling times with COVID, I can say that the company has really walked the walk when it comes to this. Working in oncology, there's been many examples of patients that have lost their jobs and as such have lost their private insurance. So Amgen has really stepped up and has been providing compassionate drug and free drug to those patients that have been affected by COVID-19 and lost their work. So they really have stuck to their mission. So there's 6 therapeutic areas that the company really covers and scopes. There's about currently 20 inline molecules or drugs that are promoted in these 6 areas. Today I'm just going to focus on the division or area that I work in, which is oncology and hematology. And within the oncology and hematology division, we actually have currently 9 inline drugs or molecules that currently you may be aware of in terms of working on. The first product that was discovered over 25 years ago is Neupogen or filgrastim. In the recent presentation, someone was showing, I mentioned a GCSF, so Neupogen is an example of GCSF. I won't go through all these molecules. The 2 that I work on are Vectibix and Mvasi. So Vectibix is an anti-EGFR therapy for metastatic colorectal cancer patients. In order to take the medication, you do have to be RAS wild type. So the work that you guys do in the labs in terms of looking at the molecular profile for colorectal cancer patients, we thank you for. And then Mvasi is the first oncology biosimilar that was launched last year for bevacizumab. So Vectibix is used quite often in left-sided colorectal patients, and for all others, we have Envasi. And just quickly, just to touch on the Victory program. So this is our patient support program that covers all of these products. So what Victory does, basically when a patient is enrolled, we offer copay support or reimbursement support. Also during COVID, if patients are enrolled in Victory, we're able to send patient materials, education materials directly to the patients, because we know that there's less patients coming into the hospitals because of the pandemic. One molecule that I will mention that actually got some recent sort of highlights and notification at ESMO just this past week was AMG 510. So it is a lung cancer product that is targeting KRAS G12C. And again, there's biomarker testing that's going to be involved for that product in order to utilize it. And it's been fast-tracked by Health Canada. So stay tuned for that one because it might be coming to your labs soon in terms of biomarker testing for patients. So just quickly, this is my second last slide. I just want to talk briefly about partnerships. So obviously supporting conferences like this, we're happy to do so. And if there are other sponsorship opportunities, we're more than open to supporting your group here in Ontario and what you're doing. One project that I wanted to mention that some of you might already be involved in. So Amgen has a strong partnership with Colorectal Cancer Canada, which is the largest patient advocacy group for colorectal cancer patients in Canada. So this group, CCC, just launched about 2 months ago a campaign called Get Personal. And really what the campaign is looking to do is to raise the awareness of biomarker testing in Canada, but also to create standardization across different cancer types. So if a patient, for example, has lung cancer, when they get their biomarker testing is different than currently what happens for colorectal cancer patients. So I'm just putting a plug in here for a campaign that they just started, and the first phase of this project is a survey. So they're actually looking for pathologists, oncologists, and GI surgeons to participate in a molecular profiling survey. So if you are interested, maybe through Heather, I can gather emails if people are interested in it, but it's basically, the survey is an environmental scan of what is happening nationally across Canada. They want to compare molecular testing and turnaround times by province. They want to identify barriers and challenges that you yourself, the clinical decision makers, are using to base their decisions on molecular profiling. And lastly, describe how the clinicians, in your opinions, impact molecular profiling and how that is related to patient outcomes to create some sort of standardization. So it's a big endeavor, and Barry Stein, who runs the CCC, has big dreams and big visions. I will mention that the survey is not just for colorectal, so it's agnostic to oncology disease sites. So if you are interested, please let us know. And it is 2:07, so on that, I will say thank you for your time. Thank you for the great presentations today, and happy to take a couple of questions if there are any. And I don't know how to see the chat if it comes in that way, but I guess you could type it through the chat box.
Thank you, Greg, for that presentation. Really appreciate you being a sponsor and for participating at the end of our day 2. And if there are any questions, you can just use the chat box or the Q&A. And if not, Meredith will come back on and she will wrap things up.
Okay, thank you everyone for staying on. I'm really glad that there's such a great contingent to stay on to hear the valuable presentation that Greg just gave us. And I will be happy to address any questions you may have for Greg after the fact. If you simply email the Ontario Association of Pathologists, we'll make sure that you are heard from. And with that, the formal program for today is wrapped. We do hope that everyone is able to join us tomorrow. We have a wonderful program put up together, and have a wonderful day, and thank you again. Oh, and lastly, at the very end of this session, you'll note there will be a survey that pops up for you, and I really hope that everyone takes the time to give some feedback as it's very helpful for aiding in what we hope will be future meetings as this. Thank you very much and have a wonderful day.
Have a great day, everybody. See you tomorrow.